Good afternoon, everyone, and welcome to the latest in Precision Roll Grinders webinar series. Today, it's Precision Coating Demands Precision Rolls for Optimum Performance. We appreciate you spending some time with us today and look forward to going through this with you. Throughout the presentation, everybody is muted just to prevent background noise, but please feel free to use the chat function or the raise your hand function within GoToWebinar. At the end of the webinar, we'll go ahead and unmute everybody so you can have the opportunity to ask questions in person as well. So we'll go ahead and get started. So how can precision rolls drive optimization in your coding process? And by coding process, there's a myriad of coding applications out there, whether it be coding online on a paper machine, coding offline on various substrates, whether it be metal, plastic, paper. Um, the principles that we're going to review throughout this webinar are consistent for each of those applications. So we would ask you to keep that in mind, but it really comes down to three pieces on how precision rolls drive optimization in your process. The first, and arguably the most important, is grinding to proper tolerances and shape. That's roundness, shape, and by shape we mean from drive side to tending side shape, concentricity, from the center line of the journals to the face of the roll. All this adds up to reducing variation in your process. And in many coding applications, it's a really fine process. It's a very thin film. It generally is very expensive coating that you're putting on. We'll go through how the proper precision roll grinding and servicing adds up. Secondly is mechanical and machining services to maximize not only the performance that drives your optimization, but to maximize your roll life too, to improve startup and to maintain excellent performance of that roll throughout the life um, of its running in your coding operation. And lastly, a value-driven approach that results in material savings. At the end of the day, um, we would encourage you to really look at your roll grinding and roll servicing as a return on investment, as a capital type investment where you should be demanding a return from your provider, your roll grinding and servicing provider. Um, it, Quite often it is viewed as just a necessary maintenance cost, and we would argue and would encourage you to really consider it as a return on investment. And we'll show you ways that can be proven in your coding operation. So driving operational excellence, driving operational excellence with precision rolls. Again, it comes down to reducing variation. And we all know intuitively that we want to reduce variation in our processes. And there are many levers to pull, from the coding recipe and makeup to the application of the coating, whether it be a blade coater, a rod coater, an air knife coater. Rolls is just one piece of it, but we think it's a very, very significant piece. And again, any opportunity that any of us have in our processes to reduce variation, we should take advantage of it. And again, and then statistically validate that we're getting a return on investment for reducing that variation. So how does variation manifest itself? Well, it manifests itself in machine direction variation and cross direction variation. Excuse me. With respect to machine direction variation, it's eliminating barring, and barring is a term that we use in roll grinding to indicate short-term variation around the diameter of the roll. So circumferential on the roll, you've got variation that almost looks like, if you were to take a reading of the outside of that roll, it looks like small gear teeth. And what that is doing is it's inducing machine direction variation, where your coding application is going from thick to thin to thick to thin as a web rides in the machine direction. That can be eliminated with optimum roll roundness and concentricity. It can also be eliminated with ensuring that your bearing seats are proper, that bearings are installed properly, and other machine parameters. But with respect to rolls, you have to eliminate that barring. Secondly, variation shows up in cross machine direction variation. That's optimum roll shape. Again, from drive side to tending side, is the roll the same shape across the web? Is it producing streaks, either thick or thin in the web? Uh, Optimum roll shape is critical. This obviously drives coating savings. Generally, a coating has to be applied to at least a minimum thickness, if you will. Um, Anything above that minimum thickness is waste, in essence, is variation that you're covering up by having to put more coating into a certain area. And the reduction of that variation can lead to significant cost savings. And then lastly, extending roll life between grinds. We will go through a slide a little later in the webinar that shows very clearly how starting closer to perfectly round allows you to run that life with that roll life with optimal results longer. It's kind of the country road washboard effect. Once the variability starts showing up in a roll, then it ends up wearing quicker over time. It's actually an exponential curve, and we'll talk through that. But again, machine direction variation, cross direction variation with respect to your coating application is critical to optimize your performance. So let's first talk about roundness. This is the machine direction variation that we were talking about. These are pictures of two actual roll grinding reports before and after. Um, you can see, well, not before and after, actually, improperly ground and precision ground. An improperly ground roll, and this can happen when it's either ground in its bearings without the opportunity to get proper roundness and total indicator run out. It also could be just an improper setup on a grinder. But you can see in the visual on the left-hand side that not only is there a slight oval shape to the roll, but there is that machine direction variation, that barring that we spoke of earlier. Although very slight, what you're doing in this case with an improperly ground roll is putting a cam, if you will, into your coating application, where now that coating is pulsing in the machine direction, if you will, um, along with the substrate as it's being coated. Whereas a precision ground roll that, although not perfect, because nothing in life is absolutely perfect, but you can see, and if you look at the scale, that scale is very, very slight. You can see that properly ground roll will provide you the proper total indicated run out and the proper roundness to eliminate significantly reduce, if not eliminate, machine direction variation in your coating process. And again, it's not necessarily dependent on the type of coater, whether it be or the way that it's being applied, but that backing roll, any rolls that you have in a coating operation, it's critical that this roundness be precise. We'll talk a little bit about some of the ways that roundness can become imprecise. And the first is grinding on bearings. And there are a lot of schools of thought out there. It runs in bearings, therefore it should be ground in bearings. And we would encourage you to really think about that. Our answer to that is no. That's incorrect. When grinding in bearings, the roll moves when it's ground. There are tolerances within each bearing. There is bearing play that can't be eliminated. Gravity affects the roll while it's in bearings being ground differently than a roll that is supported differently while in the machine. It moves in and out with those defects, and roundness at OEM specification is just not possible. Neither is true concentricity. Again, concentricity being um, the roundness of the roll face with respect to the journal center line. And lastly, the shape, which we'll talk about here in a second, is not attainable either from side to side, from tending side to drive side. So if you do have a roll grinding supplier that is talking to you about grinding it in bearings, or you're currently grinding it in bearings in-house or in place, we'd ask you to reach out and talk to us about why you should consider not doing that. That roll needs to be ground on its journals, from its journals, to provide the proper concentricity and roundness to eliminate that variation in your process. Just some typical results. You can see coding in there. Now the diameter and the face length are in millimeters, but you can see the tolerances of 1 micron in coding. This is not uncommon. Our typical tolerance at precision roll grinding is 5 microns. So we're very familiar being down in this range. 10% of our work has tolerances of less than 2.5 microns. So when it comes to applying these very expensive coatings to whatever substrate you're using, again, regardless if it's a paper machine applying a coating or a very highly technical medical patch that's applying a coating that's terribly expensive, you have to have these types of really, really tight tolerances. And then you should be able to work with your supplier to statistically validate those savings because of that reduced variability. You can see some of the finishes that are typical on the right hand side as well. Whether it be chrome roll application, rubber roll, steel, the finishes are critical too. Again, we would encourage you to reach out to Precision Roll Grinders or your current roll supplier and really be cognizant of where those finishes need to be to have the proper optimization of your coating. So at the end of the day, as we mentioned earlier, it's got to pay for itself, right? So reducing variation in coat weight, uniform material thickness, reducing material usage due to a thick or a wavy sheet. And again, we're not necessarily talking about the substrate, we're talking about the application of the coating on the substrate. And with any production of a web type product, whether it be coated or even uncoated, it's generally the case that we'll overcompensate to make up for variation, and that overcompensation is material loss. It's excess coating that is being applied to make sure that we don't have thin spots, that we don't have this barring showing up in the coating with the machine direction variation, to make sure that if there's a thin spot on the shape or the cross direction, that we're putting enough coating on to make up the difference. And again, it doesn't take long when doing so to become very expensive. It's reduced defects due to what we were just mentioning on localized thinning in a material profile. The end result is end product construction that's more consistent for your end use customer, whether that end use customer be directly to the consumer. Most generally, it's to a converter that is turning it into packaging or turning it into some other product for the consumer. The conversion of that product becomes much more consistent just because of the reduction in variation and the consistency that you're now providing your customer. So we've seen many cases where not only have we been able to work together with our customers, the folks that are purchasing the roll grinding and servicing from Precision Roll Grinders, not only have we been able to document savings just in reduced coating variation, it's a reduced coating usage, but they've also had fewer returns back from their customers, more consistent product, happier customers, in some cases been able to develop new products or regain customers that had once been lost due to quality. So the reduced defects caused by deviation in the coat weight and improved construction productivity happens with a more uniform coat weight. And again, rolls are critical. So proper shape. This is an actual before and after grind profile, and then the target profile is in green. You can see at times this one happened to be crowned, but you can see the peaks and the valleys that you don't want. You can translate that directly to what may be happening with your coating. And here's an example of that. So the target material thickness is represented by that dotted line going across the middle. And we've shaded the bottom to highlight what may be happening, right? Let's say that these valleys that you see, the one on the right-hand side being just a shade deeper than the rest, that may be the minimum quality that you're willing to get away with, or that you can get away with. That level of coating thickness is the least that you can apply. And because you've got an erratic shape in your coating profile, unfortunately, what that's doing is driving those peaks, right? And the additional material that is shown under those peaks is unnecessary and is lost. Again, any coating application with any substrate, we've seen examples of this. If we're able to produce a much better coating profile, you can see that even if that valley on the right-hand side is not corrected, um, a more consistent profile in the remainder of the roll allows for dramatically reduced coating usage. And again, we would encourage you to really take a look at this and track it over time. We'll talk a little bit about how we currently do that with our customers. This is just a really simple example of a customized spreadsheet that we put together with a customer to show the cost of improperly ground rolls. And again, these are customized for each application. There are no two coating applications that are identical. Even though they may have been designed as the same machine producing the same product, we all know, having been in manufacturing most of our careers, that they don't act the same. Shucks, sometimes they don't act the same on Tuesday as they do on Monday, right? So we would encourage you to really demand from your roll grinding and servicing provider a partnership to truly look at the return on investment. Let's validate whether or not we're saving the money that we're spending and returning a good or making a good return on that investment with respect to our roll services. And you can see this again, very conservative, about $18,000, and this is on with the cost of a grind included. In this case, a cost of a grind that's double that of a competitive grind. At Precision Roll Grinders, what we are committed to doing is showing you return on investment beyond what you would get if you weren't even paying for somebody else to grind the roll. And again, with respect to coating, it's generally shown as material savings plus any quality rejects or quality returns. We'd mentioned earlier, roll life and startup also has a lot to do with mechanical excellence, whether that be bearing inspection and bearing seat grinding, replacement, NDTs, new housings, journals, balancing, leak testing, and anything. Grinding, obviously, is a focus of what we're talking about today. But really work with your roll grinding and service provider to make sure that entire roll is being inspected properly, that the journals are right, that your bearing seats are right, that the proper bearings are being used, that the bearings are good. If they're going to be reused, that there's concentricity between the center line of the journal and the face of the roll, that the shape is correct, and that the entire integrity of that roll is where you need it or better than where you need it. Again, thorough inspection of bearings and housings. You can see some examples there on the right-hand side of bearing seats that unfortunately can look pretty typical after use, that need to be ground and properly and have the proper diameters and the proper inspection to make sure that when that roll goes back into your coating application, it's going to run right, it's going to run quickly, and it's going to run at full life with excellent results. Temperature control and surface temperature can be critical. We'll run through this quickly because we're at about 20 minutes now. Roll life and startup. This is what we had talked about earlier. This is an example of a roll that started at 2/10,000ths versus a roll that started at 8/10,000ths. In 6 months, the roll that starts at an 8/10,000ths tolerance is already at a point where it's causing enough variation in the process that it needs to be reground. Starting at a 2/10,000ths tolerance, you can see that it took 15 months to get to that same spot. Again, this is not a linear relationship. The deformation of a roll, or the wear on a roll, is a function of its deformation. So as deformation increases, the wear increases exponentially. So the closer you can start to perfectly zero, the better life that you're going to get out of that roll. And throughout that life, the more consistent product you're going to produce, the more consistent coat weight you're going to produce throughout the life of that roll. So at the end of the day, again, be asking of your roll grinding and service provider, what is the value? What value is being provided here? What is the return on this investment I'm making to have you grind and service my my roll, and particularly in a coating application? It starts with data, coat weight variability, actual coating usage, quality parameters around your process, and really doing data analysis on it. It should, that center graphic there that shows a wide bell curve to start and then a narrowed bell curve that is shifted, is what needs to happen in processes, right? To provide value, that you're able to reduce variation, and because of that reduction in variation, you can shift your process. And with respect to coating, we were putting 10 pounds per unit on. Now we're able to put 8 pounds per unit on because we've decreased the variation. We were able to shift that process to a more optimal and profitable place. And ultimately, can a predictive equation be developed and modeled that says your roll life at 6 months looks like this, at 8 months looks like this, at 12 months looks like this, or at 2 years looks like this, and let's predictively determine when grinding and servicing needs to happen, and predictively determine the kind of quality and the kind of variation we're going to have over time. That's a commitment that Precision Roll Grinders makes to their customers. And then at the end of the day, what's the case study? What are the actual savings? Tighter tolerances means bigger savings. You can kind of see on this case study a number of over $500,000 a year. Again, you can see on the left-hand side the difference, and these are actual numbers of before and after of what the profile looked like. So again, drive to these types of standards with your roll service and grinding provider. At this time, we'll open it up for any questions. I'll go ahead and unmute. Again, we just wanted to quickly go through. We've taken about 25 minutes here. Why the roll tolerances, why the roll shape, why the roll mechanical servicing is so critical in coating operations. This has been a broad overview. We would encourage you to reach out directly to a local account manager or to Precision Roll Grinders corporately with any questions that you may have, or any questions around the type of value-added studies that we do. Okay, so everybody at this time is unmuted, and we'll look for some questions. One question came up, how long do the value studies last? It really depends on your operation and what you want to study. In many operations, there's online platforms that are measuring coat weight. They're measuring other process variables that you have. If that data is readily accessible, then it's relatively quick to go ahead and do the statistical modeling on that. We've seen everything from studies that take 3 weeks to get enough data to those that take, outwards of 6 months to provide enough data to really take a look. But at the end of the day, it's got to result in dollar signs, and it's got to result in that reduced variability that we showed in the previous graph, and a shift of that variability that lets you be in a more optimal and profitable place. Another question came in, what type of roll surfaces do you work with? Really any type. We'd mentioned earlier chrome rolls, tungsten carbide coated rolls, steel and chilled iron, rubber rolls. We do work with, ceramics. There's any type of roll service. We're capable of providing the types of, generally the types of tolerances, particularly with chrome and steel, and rubber, depending on the rubber, can be a little different, but again, we'd encourage you to reach out. We also work with a number of partners that provide chroming, spray coatings, rubber covers, and we feel an advantage of working with precision roll grinders is you have another independent set of eyes on that. We don't have a vested interest in who chromes it or recovers it from a rubber standpoint, or puts a spray application on. So we can provide independent recommendations with respect to that. Okay, well, it doesn't appear at this time that there are any other questions. So again, we appreciate your time. We would encourage you to reach out to your local account manager or to us corporately with any other questions or comments regarding what we covered in the webinar today. This webinar will be available on our website within a couple of days, along with some other written information on coding. We have a previous webinar on coding that we've done as well, if you're interested in going to the website and looking at that. So again, thank you for your time. We wish you a safe and healthy remainder of the week and weekend, and we'll talk to you again soon. Thank you.